Hello everyone. Today I'm gonna start formation of images in convex mirror. Convex mirror is also known as diverging mirror. In my previous classes, videos, I have explained you why convex mirror is known as diverging mirror. Because after the phenomena of reflection, the reflected rays do not actually meet at a point. They diverge from a point. They appears to have come from some other point. That's why convex mirror is a diverging mirror, whereas concave mirror is a converging mirror. In concave mirror, children, we have learned ray diagrams for the formation of images at various position of the object. We have placed the object at various position at infinity, beyond center of curvature, at center of curvature, between center of curvature and focus, at focus. For all these 5 positions, nature of the image formed is real inverted. It always form real inverted only. Yes, nature of the image for all these 5 positions is real inverted. And size of the image also varies, changes. At infinity, size of the image, point size. Beyond center of curvature, size of the image diminish. At center of curvature, same size. Beyond, between C and F, enlarge. At focus, enlarge. See, size of the image is slowly increasing as we are moving the object from infinity to focus. When still we move further, when we keep the object between pole and focus, we have observed, we have seen that concave mirror forms virtual erect magnified image. And we have learnt the applications of concave mirror. It is used in the headlights of the automobile. It is used in the searchlights. It is used by dentists. It is used as makeup mirror. It is used as shaving mirror. It is used in the solar furnaces. So it has many applications. Converging mirror forms both real inverted and virtual and erect. Concave mirror is the only mirror which forms virtual erect and magnified image, a large image of the object. Now in today's video, children, I am going to explain you about convex mirror, which is a diverging mirror. It also forms virtual and erect image, but not enlarged, not magnified, diminish. It always forms diminished image. Let us try to form the image of an object. Here we have only 2 positions in convex mirror. We have only 2 positions. Object at infinity and object, second ray diagram that we will learn in our next video. Object placed between pole and infinity, anywhere between pole and infinity. That is 2 ray diagrams. Please listen to this ray diagram perfectly. Watch the video. Most of you are not watching the video. Please watch the video. If you have any doubt, ask doubt. Do not neglect. 10th class is very important. You must watch all sections A, B, C. Not only A. I get very good response, encouraging response from 10CA children. Some 10CB, but 10CC also. You don't be afraid of asking question to Mr. Javed. I am here to help you out. Please, you have my number 9966308529. It's my WhatsApp number. You can put your doubts on the WhatsApp. You can call me. You can clear your doubts. So children, do not sit on your doubts. Please, once again, I am reminding you to go through the videos. If you do not find, understand, you can ask questions about your doubts. Okay, children. Now, today we're going to learn formation of image in convex mirror, which is also a diverging mirror. In this case, we are placing the object at infinity. Position of the object at infinity. I told you what is infinity. Not defined distance. Object at infinity. Ultimate source of light. What is the object at infinity? Sunlight. I already told you. The rays coming from infinity, incident on the surface of the earth, parallel to each other. Whenever we see two incident rays are parallel to each other, what comes into our mind? Yes, these rays are coming from infinity. What object we have at infinity? Ultimate source of light, sun. Please remember this, children. So here also, we gonna learn where is image formed if the object is at the infinity. You can see AB, height of the object. These rays are coming from infinity. They are parallel to each other. Incident ray. Arrow mark towards the reflecting surface of convex mirror. Convex mirror, diverging mirror. See, this is a curved surface. Curved outward is reflecting. Curved inward is non-reflecting. This is behind the mirror. This is in front of the mirror. Object is placed in front of the mirror. Rays coming from infinity. How they incident? Parallel to each other and parallel to principal axis, as you can clearly see in the ray diagram. These incident rays are coming from infinity. How can we say that? Because these incident rays are incident parallel to each other and parallel to principal axis. Incident on the reflecting surface of convex mirror. Convex mirror, its reflecting surface is curved outward. Non-reflecting surface is curved inward. This is behind the mirror. This is in front of the mirror. So incident rays. How many rays of light do we require, children? We require two or more than two rays of light. So this is one incident ray. These are the incident rays. How they are incident? Parallel to each other and parallel to principal axis. We have a rule also, I told you. Whenever incident ray is incident on the reflecting surface of convex mirror parallel to each other, after reflection, the reflected ray diverges, moves away from a point. See, these are the reflected rays. This is incident ray. See, this incident ray. This is reflected ray. It appears to have come from focus. So this reflected ray should touch the incident ray. This is incident ray. For this is reflected. It is just touching the reflected ray when coming out of the mirror. The reflecting surface, non-reflecting surface. It touches the incident ray. Here also, this is incident ray. This is reflected ray. See, touching the incident ray. The reflected ray should touch the incident ray. Make a note, children. See, here also you see, this is incident ray, and this reflected ray emerging out from focus behind the mirror, touches the incident ray. This is also reflected. These are all reflected ray. So we have a rule: whenever incident ray incident parallel to principal axis, after reflection in convex mirror, diverging mirror, the reflected ray diverges from a point behind the focus. The reflected rays are diverging, moving away from a point. They appears to have come from a point behind the mirror. That point is called focus. You can see here focus. Focus, center of curvature, in case of convex mirror, lies behind the mirror. Focus, center of curvature, everything lies behind the mirror. So here, these reflected rays appears to have diverged from a point behind the mirror. That point is called focus. This is the formation of image. Where is image formed? Image is formed at focus. Where focus lies? Behind the reflecting surface, behind the mirror. Center of curvature lies behind the mirror. That's why the rays are not actually meeting after reflection. They appears to have come from some other point. That is the reason the nature of the image is virtual and erect. Second thing, you can always remember, whenever you find formation of image behind the mirror or behind the reflecting surface, then what comes to your mind? The image, in case of mirror and top, the image formed is virtual and erect. The image formed is virtual and. How can you say that? Because the rays are diverging, moving away from a point behind the mirror. They are not actually meeting. If they actually meet, real and inverted. If they do not actually meet, virtual and erect. Here you see, these rays are not actually meeting at a point. They appears to have come from a point behind the mirror. That point is called focus. That is the formation of image. Where is image formed? At focus. Image is formed at focus behind the reflecting surface or behind the mirror. So children, now we have to write for every ray diagram we have to write the properties of image formed. Properties of image formed. First property. Where is image formed? Property. First property. Image is formed at focus. Here you have to write. In case of concave mirror, what we wrote, children? In front of the mirror. But in this case, image is formed at focus behind the mirror. Behind the mirror. Same thing. Here also you have to write nature of image. There also we wrote, no? Concave mirror, nature of image. There we wrote real and inverted. Here we write what? Virtual and erect. And then size of image. Size of image, what we write? You can see clearly, size of image is point size. Size of image is point size. You can see clearly point size. And magnification, here you write plus. Why we are writing plus, children? Because plus represent what? Virtual and erect image. Plus 1 by 2, 1 by 3, 1 by 4. It means what? Diminish image. Convex mirror. Remember, children, always remember whether the object is at focus or second ray diagram. There also we will learn. Remember only one thing. Convex mirror. Nature of the image, always virtual and erect. Size of the image, always diminish. Size of the image is smaller than the size of the object in all the cases. Whenever you keep the object in convex mirror, it forms virtual and erect image. Size of the image will be always remember, diminish. What is the meaning of diminish? Size of the image is smaller than size of the object. Name the mirror which always form virtual, erect and diminish image. What comes to your mind? Oh, it's nothing but convex mirror, virtual, erect image, size of the image, diminish. Name the mirror which forms virtual, erect and magnified image. Virtual, erect and magnified. Concave mirror. Concave mirror form virtual, erect and magnified image. And plane mirror, it also form virtual, erect, but size of the image same size. Okay, now we'll discuss about these three a little later now only. Now, okay, rays incident parallel to principal axis on the reflecting surface of convex mirror, diverging mirror. After reflection, the reflected rays appears to diverge from a point behind the reflecting surface. That point is called focus. Where is image formed? At focus behind the mirror. Nature of the image, virtual and erect. Why we are saying? Because the rays are not actually meeting. There appears to have come from behind the mirror. Size of the image, diminish. Here point size, but it always form diminish image. Always remember that. Nature of the image, virtual, erect. Size of the image, diminish. Magnification will be plus 1 by 2, plus 1 by 3, plus 1 by 2. It is smaller than this. Plus 1 by 2 represent means what? Size of the image is smaller than size of the other. Plus 1 by 3, size of the image is smaller than size of 1 by 3 means size of the image is less than size of the other. Okay, now this is what about convex mirror, diverging mirror. So object at infinity, image is formed at focus. Shall we apply Cartesian sign convention? Okay, now what is object? Pole, midpoint of the strip. Pole to object. Where is object? Infinity. That is, it is always placed in front of the mirror. PB. Object distance will be always negative. Whether a concave mirror, convex mirror, object distance is always negative. Why, children? Why, Javis sir? It is always placed in front of the mirror. If you find any horizontal distance in front of the mirror, negative. Behind the mirror, positive. Remember that. So here object distance is negative. Now focal length. Where is focal length? Focus lies behind the mirror. Pole to focus is focal. This is focal length. It lies behind the mirror. If horizontal distance lies behind the mirror, positive. PF, focal length. Focal length of convex mirror is positive. Remember, focal length of concave mirror is negative. Why? Because it lies in front of the mirror. Convex mirror, focal length lies behind the reflecting surface, behind the mirror. That is why it is negative. Image distance, always positive. In convex mirror, image distance is always positive. Pole to focus. Where is image form? At focus. So I can write here again PF is V. It is also positive. Image distance is positive. Why? Because it lies behind the reflecting surface. We are measuring the horizontal distance in the direction of incident ray, that is behind the mirror. Horizontal distance will be positive. Here focal length is positive, image distance is positive only. Focal length and image distance are positive. Object distance is negative as it lies in front of the mirror. Height of the object above the principal axis, positive. Height of the image, virtual image is always formed above the principal axis. Height of the object and height of the image are positive. Here height of the object, height of the image, focal length, image distance. These four are positive except object distance is negative. This is the Cartesian sign convention in case of convex mirror, which is also known as diverging mirror. So children, listen to this carefully, read this carefully, understand the concept again and again, apply Cartesian sign convention. Okay, in my next video I am going to explain the next ray diagram, as well as along with that I am going to give you three mirrors which forms virtual erect image. What size of the image is different. Without touching the mirror you have to find out which is concave, which is convex, which is plane mirror. Without touching the board, you have to see the image of the object in the mirror and then you have to identify. That we will discuss in our next video. Till then, I'm going to catch you in my next video. Till then, be safe at home. Watch this video again and again. If you have any doubt, any questions to be asked, please ask. www.ask Jarvis. Okay now? Thank you very much for watching this video.